All right, moving into the last lesson of chapter 16, lesson 6. We're now looking at the law of cosines, and again, this is all about non-right triangles. So here's the back half of chapter 16, these three formulas, and again, they're all dedicated to non-right triangles. These work for every triangle. You could use these on a right triangle, but just keep in mind we have more efficient ways. This is a pretty complicated formula, and I'd rather not use this on a right triangle when I have easier things like SOHCAHTOA and Pythagorean theorem on a right triangle. So these are, even though these work for every triangle, they're best used for non-right triangles. Looking at the one that we're going to deal with here in our last lesson for the law of cosines, or the cosine rule, there's two ways of writing it. If you are solving for a side length, notice they isolated the a right here. So this is the sort of the best case for working with finding a side length. If you are solving for an angle measure, and you kind of do a little algebra on this to isolate the cosine a that you see right here, then they reformat it to look like this. It's the same formula, but they isolated the cosine a. So this is the best format if you're looking for an angle measure. Same formula, just reformatted, either finding an angle or finding a side length. Again, like with the other formulas, as far as A, B, and C, those are irrelevant. You may not see letters at all. You might see D, E, F, you might see X, Y, Z. It really doesn't matter. What matters on this is that you recognize that if this is side A, then this is angle A, meaning whatever this angle is, this has to be the angle across from that side. And so there's a connection between this side length and this angle. So that's really important. That would make B and C simply the other two sides that form this angle. They're next to it. They're not across from it. Okay, so this side is across from this angle, and these are simply the other two sides in the triangle. So looking at a couple examples here. So again, those are the two variations of the formula that we want to work with. If we have a triangle like we did in the last page of notes, right here was what we did for the law of sines. In these problems, we had a completed ratio. I had somewhere in the drawing, I had an angle and I had the side across from it. If you looked at this one that we did here as our last example, or first example for the last lesson, I knew an angle and the side across from it. I had a complete ratio of information. And if you have a complete ratio, you can use the law of sines. But if you don't have a complete ratio, like in this example, right, nowhere in here do I have an angle and the side across from it, so I can't use the law of sines. So now I turn to the law of cosines. In this problem here, because I know this angle, I would probably most want to find the side across from it first. So that's angle C, so let's just call this side C. So we're going to find side C first. So because I'm finding a side length, I'm going to go with that scenario right here. And do keep in mind that when you're doing this, this side is across from this angle. So if I'm finding side C, then this is the angle that's going to go right here within my setup. So I'm going to say for this one, C squared. So if that's the side I'm working with, then these are the other two sides. So those represent him and him. So I got the 6 squared plus 10.5 squared minus 2, 6 10.5. And then I got my cosine of an angle. In this case, our angle is 69 degrees. And again, the thing that matters most here is this side has to be across from this angle, which you can see that's what we have. So I know my setup is good. All I have to do now is do a little cleanup here and get C by itself. So all of that can go in my calculator. I will then square root both sides in order to solve for C. So if you go through that and do the math, side C is going to come out to be about 10.1. If you're following along with the notes for the first time, I really encourage you to try that in your calculator. because that can be an issue. Oftentimes students will have the correct setup. They have a hard time putting all that into a calculator. So I would give that a try and make sure you can come out with that correct value to know that you're putting it in your calculator correctly. Anyway, we now know that side C is 10.1. So let's fill that into our diagram. And now, again, kind of like with the other problems, we're just solving the triangle. So my goal is to find everything that's missing. So in this case, I still need 2 more angles in order to complete the triangle. You have options at this point. You now have a completed ratio. I have an angle and the side across from it. So the law of sines is fair game at this point. You can still use the law of cosines. You have options at this stage. So do what makes most sense for you. In this case, and there are a few rare cases where you really need the law of cosines. It's a safer route. So when in doubt, I actually would advise you to use the law of cosines instead of the law of sines, because the law of cosines is sort of a more sure route. There are some rare scenarios where the law of sines is kind of an issue. Law of cosines always works, so it is the safest route. But if you wanted to try using like the law of sines at this point, we could try doing what we did in our last lesson to figure out the rest of our stuff. So in this case, if you were to try something like the law of sines, you could now say my 10.1 over sine 69. So there's my completed ratio, and I could just match that up with an incomplete ratio like 6 over sine b. Right, and again, on this one, you would eventually need an inverse sine function in order to get angle B, since you're solving for an angle, so do keep that in mind. But if you cross multiply, do an inverse sine function just like we did in the last video, you would find angle B should be about 34 degrees. And of course, I can subtract those from 180 in order to get angle A, which should be about 77 degrees. Okay, so moving on to one more example. Looking at example 2, just a little different scenario. Notice in this one we now know all 3 sides, but we don't know any of the angles. Again, the law of sines is out because nowhere do I have a completed ratio. I don't know any angle and its opposite side. So I have to turn to the law of cosines. And in this case, just pick your favorite angle and we'll solve for that first. I'm just going to pick angle A. It really doesn't matter which angle I go with. I'm just going to start with angle A and go from there. So remember that we are now going to use the other format here. Because I'm solving for an angle measure, I want to go with this format that I see. Most importantly, just remember that whatever this angle is that you're solving for, this has to be the side across from it. And these are just the other 2 sides. So the letters are irrelevant. You just have to make sure that certain things match up within the formula. So in this case, if I'm solving for angle A, then I'm going to say cosine A. And on the other side, if I plug into the formula that we have, solving for this angle, so these are the adjacent sides, so 2.4 and 6.8. Minus 6.6 squared. So that's everything that would go on top. On bottom, if I fill in the rest of that guy, so looking at this again, looking at this formula right here, so this same number and this same number are those 2 numbers. So going with what we have so far, I can now plug in my 2, 2.4, 6.8. So that would be our setup. The rest is calculator work, and as always, you are solving for an angle measure, so you're going to have to do the inverse cosine of all of this in order to get your angle. So try punching all that into your calculator, see what you get. Should come out to angle A being about 75 degrees if you do that right. And so as always, I'm going to punch that in, draw that into my diagram, and go from there. So if you wanted to continue solving for all the other information, it would be the same thing that we just did in example 1. You could now use the law of cosines or the law of sines to continue finding your other 2 angles.